In this particular lecture, we are going to discuss about different pressure transmitter symbols for the P&ID. We'll be discussing about the pressure transmitter and differential type pressure transmitter. Both we are going to discuss in this particular lecture. So the pressure transmitter are normally uh, depicted as shown in this figure. So as you can see, if it is a vessel, right? In the vessel, on the top of the vessel, you will just show a PT here. If it is a line, you can show the PT like this. One line, and after that there is a PT. Very simple. And for the DPT, if it is a, suppose there is a filter, and across the filter you need to know the what is the differential pressure. So it is shown as the two lines because there are two tappings. Here is a tapping and here is a tapping. So um, in between this are shown. Sometimes you will also see that the PT or the DPT, they are shown with a root valve here. So basically there is a valve here. There is also a valve here, and on the side you will also seeing the size of the valve like 3 by 4 inch. This is a normal tapping, and from here the DPT impulse tubing it gets connected. So another important thing to mention here is so PT can be hooked up in a multiple different way to the process connection. It can be through impulse piping. It can be through diaphragm seals. Okay. So mostly if it is a impulse line, it is shown like this, only a single line here, here, everywhere, right? But it is a diaphragm seal, it will be shown in a different way. I will show in a moment how it looks. So basically you see that this is, if it is an impulse pipe and mounted on a vessel or pipe, it is basically shown like this. Additionally, everywhere you will be finding one valve here, which is like a root valve to isolate the PT, right? In some cases, in additional, you may also find the PT is like this. You may also find additional showing this is a valve, and there is a drain valve here out there, and this is where it is connected to the line. Okay, sorry for this drawing. So uh, there is a valve here which is a basically drain valve, and this valve is basically isolation valve. Okay, so another thing is PG, pressure gauge. Pressure gauge is like this one, and they are also shown, like it can be shown as a PG, or some places you will be seeing that it is shown as PI also, like pressure indicator, right? So it is shown like this. Okay, now in some cases from the same tapping, both PT and PG are shown. So how that looks like, see, basically if it is a single tapping, then there will be a first root valve here, and from the root valve you will be seeing one PT here with a root valve here, and then maybe another PT, or suppose in this case we see there is a PG, so this is will be shown as PI or PG. So this is not a very good configuration because uh, this problem of this particular tapping will cause the both PT and PI to malfunction. But in some cases, due to the process restriction or the unavailability of additional tapping, this kind of configurations are also seen. Another common thing is 2 out of 3 or 2 out of 2 PT. So they can be in the pressure here or somewhere else. So how they are shown is basically if you have it can be one PT, then there can be another PT, there can be another PT, and there are tags attached to it. So for example, here it will be written 1, 2, 3, 4A, it will be 1, 2, 3, 4B, it will be 1, 2, 3, 4C. And then the signals, like going from here, it will be shown it is going to a 2 out of 3 blocks, right? And this then goes to some interlock or some other places. So hope this concept is clear. First of all, if it is an impulse line, it will be shown as a single line and then PT or PG. Normally, the valve is also shown, the root valve is also shown. And if the same tapping is used for both PT, PG or multiple different PTs, then it should be shown with only one line. From this, you will understand then there is only one tapping. And from this tapping, there are three different routes that are given here. Only one major concern is sometimes in the P&ID, root valves are not shown or root valves are not shown correctly. So you need to check other drawings like isometrics or detailed hookup drawing of the instrument to understand more detail what are the different components, because P&ID is little bit high level. So if there is a small valve in the impulse piping, they many times that are not shown in the P&ID. Only the main root valve and the piping components are shown in the P&ID, but the instrumentation valve, instrumentation manifold, they are normally not shown in the P&ID. If you have some doubt or comments, you can write in the questions box or in the comment box. Okay, now look into another different type of the pressure transmitter. So this is a diaphragm seal pressure transmitter. So in this case, there is a flange connection basically on the vessel or on the pipeline, and on the flange, the the flange of this kind of a flange is this kind of flange gets attached through the nut bolts, right? Through this nut bolt, it gets attached, and this is the diaphragm and this is the capillary tubing, right? So this kind of a diaphragm seal is used when the liquid that is very toxic, right? That may damage the diaphragm of the transmitter. Or sometimes if the pressure is very, very low, so that time also diaphragm seal helps to measure the pressure accurately. So this is how it is shown here. You can see, you will be seeing this diaphragm symbol here, and after that there is a capillary, and after that this PT is mounted, right? So, and for the DPT also the same case. Okay. Okay, so hope the concept of diaphragm seal, pressure transmitter, DP transmitter, and the pressure transmitter, normal impulse type pressure transmitter representation in the P&ID is clear to you.